Welcome to our YouTube channel Incredible Maths. In this video we will solve a problem asked in CSIR NET June 2023. So this problem is from complex analysis. So here we need to find the value of the integral. So to find the value of the integral, so we will use Cauchy's residue theorem. So Cauchy's residue theorem, so the value of integral is given by 2 pi I into sum of the residues. 2 pi I into sum of the residues. So therefore we need to find the residue here. So from this integral, given integral, f of z is 1 by z square into e power z minus e power minus z. So first we will find the poles of this function f of z, then we can find the residue. So before finding poles, we will simplify this function f of z. So first we will find z square into e power z minus e power minus z. So this can be written as z square. So we will apply the formula for e power z, series expansion, and similarly for e power minus z. So we have 1 plus z by 1 factorial plus z square by 2 factorial plus z cube by 3 factorial plus etc. minus of 1 minus z by 1 factorial plus z square by 2 factorial minus z cube by 3 factorial plus etc. So we can simplify this one. So 1 and minus 1 will cancel, and z square by 2 factorial, and this is minus z square by 2 factorial. So it goes on like this. So we will get finally z square into 2z by 1 factorial plus 2z cube by 3 factorial plus 2z power 5 by 5 factorial. So all even powers will be get cancelled, so only we will only have the odd powers plus etc. So this can be written as, so we can take this z from here, so 2z cube. So 2z cube times 1 by 1 factorial plus 2z square by 3 factorial plus, okay, so 2 we have already taken out, so therefore this one plus z power 4 by 5 factorial etc. So our f of x is 1 divided by this one, so 1 divided by 2z cube 1 plus z square by 3 factorial plus z power 4 by 5 factorial plus etc. So from this we can see that z equal to 0 is a pole of order 3. Okay, so here z equal to 0 is a pole of order 3. So to find the pole, so we have to equate the denominator to 0. So when we equate the denominator to 0, so we will get z cube equal to 0. So z equal to 0, 0, 0. So therefore z equal to 0 is a pole of order 3. So therefore we have multipole. So now we will see how to find the residue for this function f of z. So the formula is residue of f of z at z equal to a when we have multiple pole. So the formula is 1 by m minus 1 factorial. So this is for pole of order m. 1 by m minus 1 factorial d power m minus 1 divided by dz power m minus 1, limit z tends to a, z minus a power m into f of z. So we will apply this formula here. So now in our case, the residue, we have to find the residue of f of z at z equal to 0. So residue of f of z at z equal to 0 is given by, so here we have pole of order 3, so here m equal to 3. So therefore 3 minus 1 factorial, that is 2 factorial, that is 2, d square by dz square, limit z tends to, okay, so we have to write this here, okay, so we will write this. So this one, so come here, limit z tends to a, d power, so z tends to 0 here. In our case, d square divided by dz square, z minus 0 power 3, 1 by 2z cube into 1 plus z square by 3 factorial plus z power 4 by 5 factorial plus etc. So this is equal to, so you get 1 by 4 here. So 1 by 4, limit z tends to 0, d square by dz square. So this and this we will cancel. So we have 1 plus z square by 3 factorial plus z power 4 by 5 factorial plus etc. So this is equal to 1 by 4. Limit z tends to 0. So you have to differentiate this twice. So this will become minus 1. So when you differentiate once, you get d by dz of minus 1 times 1 plus z square by 3 factorial plus etc. power minus 1. So we get differentiate inside the bracket. So 0 plus 2z by 3 factorial plus etc. So now we have to differentiate once again. So 1 by 4, limit z tends to 0. So we differentiate this once again. So it will become, so this is minus 2. So minus 1 minus 2, it's 2, 1 plus z square by 3 factorial plus etc. minus 3, and we will differentiate inside the bracket. So we will get the same thing. So we get this is 2z by 3 factorial plus etc. This one square plus, so we have to apply the UV rule here, so product rule. So this we will have, so it is minus 1, 1 plus z square by 3 factorial plus etc. minus 2. Here we have to differentiate this. So we get 2z, when you differentiate we get 2 by 3 factorial. So the next term will consist of z. So the next term will be z power 5 by, okay, so z power 4, z power 4 by 5 factorial. So we will get here. So here when you differentiate once, you get 4z cube. So differentiating again, for 12 z square divided by 5 factorial. So therefore when we apply limit z tends to 0, so we will have, so the first term, so this will become 0. Okay, so inside we'll have some value 1, so 2 into 1, so we will apply here 2 into 1 power minus 3, so this will become 0. So when you apply z equal to 0, so all terms will become sub z, it will become 0, plus minus 1, so here 1 plus 0, so 1 power minus 2, and here it is 2 by 3 factorial 6, and rest of the terms are 0. So this is equal to, so 1 by 4 times minus 2 by 6, so this is equal to minus 1 by 12. So the value of the integral, so that is 1 by z square into e power z minus e power minus z dz. Okay, so this is equal to 2 pi I into sum of the residues. Sum of the residues is minus 1 by 12, so this is equal to minus pi I by 6. So this is the correct answer. So now we will check the option. So minus pi I by 6, so the option D is correct, so the rest of the options are wrong. So this is a part B question, it has only one correct option, so the correct option is option D. If you like the content of this video, kindly like and share with your friends. Also subscribe our channel. Thank you.